All right, we are taking a look at chapter 6 now, and in this chapter, we will be graphing trig functions. If you have your chapter 5 notes handy with you, it would be helpful to be opened up to your unit circle because we'll be referencing that a lot. In fact, throughout all of chapter 6 and chapter 7, having your unit circle out and better yet memorized will be really helpful. When you get to calculus, you need to know your unit circle. You've really got to know, as easily as you know 2 plus 2 is 4, you need to know cosine of 3 pi over 4 is negative root 2 over 2. All the angles around the unit circle, you really need to know thoroughly. So better than having that out would be to have that memorized. And so if you haven't done that yet, get that memorized because you're going to need it. And we're going to go ahead and graph the first sine function here. And I've already filled out this table using my unit circle, which again, I have memorized. Sine of 0 is 0, sine of pi over 6 is 1/2, and so on all the way to 2 pi. So we're going to plot these points to get an idea of what the sine function looks like. And then I will show you how to graph this without using this many points every time. So sine of 0 is 0. Sine of pi over 6, this is pi over 2, pi, 3 pi over 2, and 2 pi. And then we're counting by every 30 degrees inside of that. So pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, 2 pi. So if you're thinking about your unit circle, what we're doing is counting around that unit circle: pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, 0, or 2 pi. So that's what we're doing here, and we're plotting those points. So at pi over 6, it is 1/2. At pi over 3, it's root 3 over 2, which if you type that in your calculator, you get about 0.87. So not quite all the way to 1 yet. And then at pi over 2, it's equal to 1. And then at 2 pi over 3, it's root 3 over 2 again, 1/2, and then 0, and then negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2, negative 1/2, and 0. So if we connect all of those dots, this gives you the shape of the sine curve. And we won't use that many points every time. We will use 5 points. The start, the end, halfway is going to also be 0. So those 3 are all 0. And then the first quarter point is the maximum at 1. And the third quarter point is the minimum at -1. And so we'll use those same 5 points every time we graph sine. In fact, your graphs will all look the same. What may change is this number on the side or what we have on the x-axis. And so when you're graphing these equations here, what I will be looking for is having those 5 points on your x-axis labeled. You'll have to have the number written for each one of them. And then I'll also want to see your amplitude here at the y-axis, how high your graph goes and how low it goes. And but the shape of your graph will pretty much stay the same all the time. So cosine is similar, and these again are all the values from the unit circle. And so we can go ahead and plot those points. So cosine of 0 is 1. So it does not start at 0, 0. It starts at 0, 1. And then it's root 3 over 2, which is about 0.87. And then 1/2, 0, negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2, negative 1/2, 0, 1/2, root 3 over 2, and then back up at 1. So cosine's graph is a little bit different. I didn't draw the curve super well here, so let me try and fix it a bit. It should be a little more curved here than I drew it here, but this is the graph of cosine. It's the same function as sine. Let me just underneath it real quick, draw it a little bit better. This is what it should look like, a little more curved there. And then this would be 3 pi over 2, and this would be at pi over 2. All right, so that's what the cosine graph looks like. And it is 0 at its first and third quarter points right here. And then it starts up at 1 at its maximum. And then halfway through, it hits its minimum at -1. So again, you'll need to have your x-axis and y-axis labeled clearly for these graphs, following these 5 points in order to get credit for these graphs. All right, and you know what? Let me actually connect this back to something we did in chapter 5 really quickly here. If you're looking at your graph, if you're looking at your unit circle here, if you think back to quadrant 1, 2, 3, and 4, quadrant 1, all of them are positive. Quadrant 2, only sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive. In quadrant 4, cosine and secant are positive. And so we can use that information and connect it to these graphs here. If we're talking about where cosine is positive here, well, 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. Pi to 3 pi over 2 is quadrant 3. And then 3 pi over 2 to 2 pi is quadrant 4. And all of them are positive here. Sine is positive here, so cosine is negative. Quadrant 3, tangent is positive here. And then in quadrant 4, cosine is positive. So we can see cosine positive where cosine is positive, and cosine positive in quadrant 1 where all of them are positive. And then in quadrants 2 and 3, cosine is negative. So let's look at the graph of sine and cosine. Some information here at the top of the page, just about the fact that these are periodic functions. That means they complete the same cycle of the graph every 2 pi. So that same curve that we just drew, it continues on in both directions, that same cycle. And then the domain of each function is -infinity to +infinity. It goes on forever in each direction. And the range is from -1 to 1. And it does actually equal -1 and 1. So we have brackets there. When we are graphing sine and cosine, like I just mentioned before, we'll find the amplitude. That's how high and how low it goes. And then the period. And then the 5 critical points, so where it touches the x-axis, the maximum, and the minimum. And then we'll draw our curve. Now, normally sine starts at 0 and goes to 2 pi for one period, but we can also have shifts of the sine function. So if you notice here, we can have numbers attached to the x, we have numbers subtracted inside, a number up front. And so those things all change the length of the period of our function. So if I want to find out what my graph starts at and ends at, if I have things added and subtracted in here, then I can set the inside of my sine function in between 0 and 2 pi and solve for x. So if I add c to all 3 sides here, then that's gone here, and I have c is less than or equal to bx less than or equal to 2 pi plus c. And then I can divide by b everywhere. And then I end up with x by itself in between, c over b here, and then 2 pi over b plus c over b, which is exactly what I have right here. And this is my new ending, and this is my new start to one cycle of my graph. The horizontal shifting left and right is called the phase shift. The amplitude tells us how high and how low our graph goes. And then the period of our graph is 2 pi over b. Now, if we add a number onto the end, then that also gives us a vertical shift of our graph. So those are the 4 different ways our graph can shift. And then cosine works the same way as sine. So we're going to graph some examples here. And we have the first one here where it says, determine the amplitude period. Oh, you know what? Actually, sorry, this is the first example here. Y equals -3 sine x. So the only change that has been applied to this one is that now we have an amplitude. So my amplitude is equal to 3. It's the absolute value of that number. That means the highest my graph goes is 3 and the lowest it goes is -3. but there's no period change. So one period is still going to be from 0 to 2 pi. And then this asks us to graph two periods of that function. So this is my amplitude. And remember, sine starts at 0, it ends at 0, and halfway is 0. And then at that first quarter point, it normally is up at the maximum, but because we have a negative on the front of the function, it actually is going to go down at first. So down to its minimum and then up to its maximum. And this gives us one period of that sine function. Well, they asked us to graph two periods, so we're going to continue this pattern into the next period here. And that would be two periods of this sine function. Looking at the next example, we have the cosine function, and it has an amplitude of 1/3, and it also has a period change of 2. So we're going to look at how that affects the starting and ending of our graph. So normally cosine starts at 0, and we'll have 2x, and then it ends at 2 pi. Well, to solve for x, all I need to do is divide by 2 everywhere. 0 divided by 2 is still 0. And then x, and then 2 pi divided by 2 is pi. And so my graph is going to be complete from 0 to pi. Now, there's no negative out front, so cosine still starts up at its maximum, and it ends at its maximum. Halfway between is its minimum. And then at the first and third quarter points, it has its zeros. So this is one period of that cosine graph. Now they asked us to graph from negative pi to pi. So from 0 to pi was our start and end for this graph. I'm going to copy and paste the same thing over here. So following that same pattern, 0, minimum, 0, maximum. And so we can see two periods of that cosine graph there. Again, you can see that I have everything labeled here. Now, I see it for one period, every point labeled. If I ask you to graph two periods, just give me it like halfway and the ending point. You don't have to do every single one for all of them. But for at least one period of it, I need to see all 5 values there, clearly labeled, your amplitude clearly labeled. All right, the next one is -3 cosine pi over 2x, and we want from -4 to 4. So again, pi over 2 x is normally from 0 to 2 pi. And so I'm going to try and get that pi over 2 off of the x. And the way I can get that off the x is by multiplying by the reciprocal, so 2 over pi. And when I multiply by 2 over pi, my 2's cancel and my pi's cancel, and I have x by itself in between. 0 times 2 over pi is still just 0. And then here my pi's cancel, and I have 2 times 2 is 4. So now my graph starts at 0 and ends at 4. Not 4 pi, but just the number 4. There's no pi's in my x-axis values now. So this graph is going to be going from 0 to 4. And then I'm going to graph it, another period of it going all the way to -4. The amplitude is 3, but notice that I have a negative up front. So normally cosine starts up at its maximum, but now it's going to be starting at its minimum. It's reflected across the x-axis. And then we hit our x-intercept. Now what was normally our minimum is now the maximum, x-axis, and then ending. And that gives us one period of cosine. And then I can continue that pattern here going the other direction. And there's our graph. So you can see that like my graph itself is not actually changing from one example to the next very much. What's changing is how I label my x-axis and then my amplitude. The next example here says determine the amplitude and period for 3 sine 2x and then graph it from 0 to 2 pi. So now we do have a period change on this one as well. So 2x between 0 and 2 pi. We'll divide by 2 everywhere. So 0 to pi is 1 period. So 0 to pi will be 1 period. It's not negative, so it will go up first, but my amplitude is 3, starts at 0, ends at 0, halfway is 0. And that's what our pattern is for sine. At the first quarter, we hit our maximum. At the third quarter, we hit our minimum. And that is 1 period. And then we can continue that pattern in the next period. It's like copying and pasting. And there's 2 periods of that sine function. All right, and on the next page, we have a few more examples. We're going to see a little bit more complication in these examples where we have a phase shift now. So in this first example, I can see that I have 4 sine of 2x plus 2 pi over 3, and I want to graph 1 period. So I'm going to put that 2x plus 2 pi over 3, 3 in between 2 pi and 0. First, I'm going to subtract 2 pi over 3, and that cancels out. So I have negative 2 pi over 3 less than or equal to 2x less than or equal to, and 2 pi minus 2 pi over 3. Let's kind of do this off to the side for a second. 2 pi minus 2 pi over 3. In order to subtract, I need a common denominator, so I'm going to multiply by 3 over 3. So that becomes 6 pi over 3 minus 2 pi over 3. And 6 pi minus 2 pi would be 4 pi over 3. All right, and then the next thing I need to do is divide by 2, or I can multiply by 1/2, which is the same thing. And doing it that way, it makes it a little easier for us to reduce our fractions here. So now my graph starts at negative pi over 3 and then ends at 2 pi over 3. And this is the sine graph. My amplitude is 4. So it's starting at pi over 3 and ending at 2 pi over 3. So starts and ends at 0. And I need to find that halfway point. So there's a couple ways you can find the halfway point. One option is for us to try and come up with a common denominator that I can count by here. Another way is for us to add these together and divide by 2. So if you think of like averages, if you have 2 test scores, let's say you got a 70% and an 80% on your 2 exams, you add those together and divide by 2, and that gives you your average. Well, I can find the average of these 2 points, or the halfway point, by adding them together and dividing by 2. So negative pi over 3 plus 2 pi over 3, dividing by 2 or multiplying by 1/2. And that would give me negative pi plus 2 pi would be pi over 3 times 1/2 would give me pi over 6. So that tells me that halfway between would be pi over 6. The other way you could have gotten that is gone 1 unit in. So I'm counting by pi over 3s here. Negative pi over 3, 0. 1 pi over 3, 2 pi over 3. So going in 1, and then the halfway point between these two would be pi over 6. Remember, sine is also 0 at its halfway point. And so now I need to find the average between these two. So I could go through that same process again. I could do 1/2 and negative pi over 3 plus pi over 6. Well, pi over 3 I need a common denominator for. Again, I can multiply by 2 over 2, and then that would become negative, or not negative 1/2, positive 1/2 times negative 2 pi over 6 plus pi over 6. And that would give me negative pi over 6 times 1/2, which would be negative pi over 12. And then I could do the same thing between here and here, pi over 6 and 2 pi over 3. I'm starting to run out of room here, but I think I can squeeze it in up here. 1/2 and pi over 6 plus 2 pi over 3. 2 pi over 3 I can multiply by 2 over 2, and that becomes pi over 6 plus 4 pi over 6. That gives me 1/2 times 5 pi over 6. And then that would be 5 pi over 12. And that's halfway between these two. Now, most of the ones like on a quiz or an exam wouldn't be as complicated as the one I'm showing you, but I wanted to show you an example of how to find those points. All right, so Again, sine starts at 0, ends at 0, halfway is 0. At that first quarter point, it's up at its maximum. It's not negative out front, so it will go up to its maximum at that first quarter. And then at the third quarter, it's down at its minimum. And so this gives us the graph of our sine function. All right, the next example, we have cosine, and it also has a phase shift and all kinds of different changes on it. So I have 4x minus pi, and it's normally between 0 and 2 pi. I'm going to add pi, and that is gone, and I have 4x between pi and 3 pi. And dividing by 4, that gives me pi over 4 x and 3 pi over 4. So that's my start and my end for this cosine function. My amplitude is 1/2. So I'm starting at pi over 4 and ending at 3 pi over 4. If you think about your unit circle, if I have pi over 4 and 3 pi over 4, halfway between that is pi over 2. And then I can find my halfway points between there. So that's my start and my end. Remember that cosine starts up at its maximum, and it is positive, so it will start at the maximum. And then halfway it's at its minimum. And then these will be our zeros, but I still need to find those x values, even though I actually have enough to draw my graph. My x values here and here, well, pi over 2 and 3 pi over 4, if I want to, I can go ahead and change pi over 2. This is another way you can kind of do this. Let's say pi over 2 and 3 pi over 4. Pi over 2 I could change to 2 pi over 4. And I need to average between 2 pi over 4 and 3 pi over 4. Well, if I multiply by 2 over 2 again, if I change this to, instead of 2 pi over 4 and 3 pi over 4, 2 pi over 4 would become 4 pi over 8, and 3 pi over 4 would become 6 pi over 8. Then halfway between would be 5 pi over 8, halfway between 4 and 6. So this is 5 pi over 8. So I've shown you a few different ways now how you can find these in-between points when you have difficult numbers. So you have a few options here. Let's do the same thing for pi over 4 and pi over 2. So if I have pi over 4 and pi over 2, and I want to find the halfway between, well, we had a denominator of 8 here. Let's try to make a denominator of 8 here. If I multiply by 2 over 2 here, that becomes 2 pi over 8. And if I multiply by 4 over 4 here, that becomes 4 pi over 8. Well, halfway between 2 and 4 would be 3 pi over 8. And the more you practice this, the better you're going to get at it, and it'll become easier. So those are the other x values there. All right, so that is that graph of cosine. We have 2 more here. The next one is giving us one with a vertical shift, which we have not done yet. And it can be helpful for you if you just kind of really lightly in pencil. This is a vertical shift of down 1. And normally the x-axis is kind of where everything is centered. I'm just going to give us this really light dotted line here down 1, because that's going to be like our new x-axis. So this is just the regular cosine. There's no phase shift. There's no period change. It's going from 0 to 2 pi. The amplitude is 3. So I'm going to graph 3 cosine x without the vertical shift first. So it starts up at 3. It ends at 3. The quarter points are my roots. And then my halfway point is my minimum there. And all of these points are going to move down 1. So all of these points move down 1. This shifts down 1. This shifts down 1. This shifts down 1, down 1, and down 1. And that is the graph that I want. And there's our cosine graph. Okay, so this next one gives us a graph, and we want to write the equation. Now you can actually make this fit for sine or cosine, but I see cosine right away. If you look at from 1 to 7, that looks like the shape of cosine. So I'm going to use cosine. And that means I'm trying to make this fit into y equals a cosine bx minus c plus d. And it is clear that it has been a vertical shift. If we look at where the top is at 1 and the minimum is down at -5, halfway between that is kind of like what our new x-axis is. And so this has been shifted down 2. So I can already see that my vertical shift is -2. And then the distance from the halfway to the top and from halfway to the bottom is 3. So that means my amplitude, my A value, is 3. So the only pieces I really need to solve for here are B and C. Now, I see that it's normal cosine where it starts at its maximum, so I know that this is a +3. But if it had been below, starting down below, then I would have used -3 for my amplitude. Now it starts at 1 and ends at 7, and the length of that period then is 6. So what we're saying is if our period, which is normally 2 pi over b, equals 6, then I can solve for b. 6 is the same thing as 6 over 1, and I can cross multiply. 6b equals 2 pi times 1, which is 2 pi. I can divide by 6, and then b equals pi over 3 after we reduce there. So we just found our b value, pi over 3x. And the last thing I need is my c value. So I shifted over 1. Now, if I want to find my c value, I know that my phase shift is 1, and your phase shift is normally c over b. Well, I know my b value, and I know that it shifted over 1. So I know my phase shift is 1. Put the minus sign there. And I know my b value is pi over 3. So c over pi over 3 equals 1. I can rewrite that as c times 3 over pi equals 1. Now remember, when you divide fractions, you flip the bottom one and change it to multiplication. So that's what I've done here. So I have 3c over pi equals 1 over 1, which is the same thing as 1. You can cross multiply. 3c equals pi. So dividing by 3, c equals pi over 3. So minus pi over 3 here for my phase shift. And that brings us to the end of this first section in chapter 6.